Alright, today instead of revolving it around a particular axis, what we're going to do is we're going to get these shapes, okay, these geometric shapes, whether they're squares, isosceles triangles, equilateral triangles, semicircles, and we're going to put them on top of the bounded space. Okay, so let's say we had a flat space like this and we're getting that cross section like a particular rectangle and we're putting it on there. And I'm putting a whole bunch of them on there for that entire shape. And what it's doing is it's creating a three-dimensional shape that's coming up like that. The idea is to put an infinite amount of them, right, to be able to complete it and make it a solid figure. You understand? These are pretty easy to tell because they'll say, oh, this bounded space has a cross section, and it tells you the shape of the cross section that's on it. Yes? So again, they could be squares, they could be isosceles right triangles, equilateral triangles, or circles. Those are usually the four that come up on the AP test. Last year on the funnel problem, they put circles. Okay, but if you know the general formula for working with volumes due to cross sections, you should be okay and still be able to apply it to anything. Okay, we're going to go over these four, and it's going to be another 4 formulas to memorize other than the other ones that we learned.
Another 4?
Another 4 to memorize. Okay? To remember, I was going to say remember, but memorize at the same time. Yeah, rememberize. Okay? Cool? Alright, so for the first one, okay, something that I didn't include here on the notes is they're going to tell you whether the cross sections are perpendicular to a particular axis. So if they say that the cross sections are perpendicular to the x-axis, you know it's a dx problem. You know that to find the width or whatever measurement of you need of the base of that cross section is going to be top minus bottom. Okay, if they say it's perpendicular to the y-axis, so my cross sections are not vertically like that, they're going to be horizontally. I'm putting them like this now, right? So that's going to be a dy problem. They said perpendicular to the y-axis. Now sometimes they might be tricky to try and trick you, and they might say, oh, the cross sections are parallel to the x-axis. So if they're parallel to the x-axis, that means they're what? That means they're perpendicular to the y, so therefore it's a dy problem, not a dx problem. Okay, so be careful. Right? Don't let them punk you like that. So, the ones we're going to be doing are all going to be dx type problems, but there could be some dy problems, and we'll look at some of those later. Cool? Alright, so you can see that they're putting these square cross sections inside of the shape, and the base right there is going to be found, okay, this length down here at the bottom. I can find it by doing the top function minus the bottom function. So that's why they did f of x minus g of x. Now we know that a square, all the sides are equal, right? So this bottom piece is going to be the same as the height that's going up, right? Which will be f of x minus g of x as well. Now if I find the area of that cross section, right, and then I add up all the infinite areas of each cross section, then it'll create the volume of that solid that is created by putting those cross sections on the shape. You understand?
Yeah.
So what we need is we need to figure out the area of that square. How do I get the area of a square? Length times width, right? So in this case, they're both what? F of x minus g of x, so in this case, it's just that what? Square. Yes? Now that's just the area of one of them, right? Now if I want to make infinite of them, and I want to add them all up, that's where I need an integral, right? Because the integral is the summation, okay? And it would be the summation of all those areas of each different cross-section that would add up to be the volume of that three-dimensional figure, okay? So if the cross-sectional areas were added up, the total would be the volume of the solid picture. Okay, so how do we write that using an integral? What do you think it would be? The integral from a to b, right? Of that area, which is f of x minus g of x squared dx. And that would equal to the volume of that three-dimensional figure that's coming up. Easy? This one doesn't have a pi in it, okay, because it's not a circle. Yes? They're not cylinders, not discs. Try the next one. What if we were on isosceles right triangle? And one of the legs was on the base of the shape, right? So again, this picture is turned sideways so you can get a better aspect of it, but it's actually like this. So the cross sections are perpendicular to the x-axis as well. Okay? So how do I find the area of a triangle? Because I'm going to need that.
Base times height divided by 2.
Base times height divided by 2. So it would be this times this divided by 2. So that would basically be f of x minus g of x squared divided by 2, right? Isn't an isosceles triangle half of a square?
Yeah.
Right? So the area of an isosceles triangle should be half the area of a square. Right? So if I add up all those areas, what would be the formula that I could use to do that? I'm going to take that 1/2 out, and I'm going to put the integral of f of x minus g of x what? Squared. So it's what I had for the squared, but just divided by what? By 2. From A to B, very good. Wherever to wherever. Most of the time, those will be intersection points between the two points. Seems easy? Sounds easy, right? All you gotta do is remember the formulas. Now, what f of x and g of x are gonna be depends on the functions that are given, right? Okay, now whether I do top minus bottom or right minus left to get those, depends on what I'm perpendicular to, the cross section, right? Remember that. So the next one is equilateral triangles. This one's fun. Right? So equilateral means all the sides are what? Equal, so that means each angle inside should measure how much? Not 30. 60, right? Because they have to add up to what? 180. Remember that? Okay. So area of a triangle we said was base times height, right Martin?
Yeah.
So base would be this. The height, I would have to draw it. And when I draw that, what happens to this angle that was 60 up here?
You get split
Well,
in half
this-
to
Now it becomes 30, right? So now we have a special right triangle. Do you remember those? 30, 60, 90? Okay. You don't remember? Back in the day when you took geometry?
yeah, the good
What was the
days.
rule for this? X radical 3, 2x. Okay? So the main goal on this one was always to find that small leg, that 30, right? The one across from the 30-degree angle. If I knew that one, then I could figure out all the other ones, right? So the one across from the 30 is this little piece right here, which is how much of the whole base? Half of it, right? So I know that this guy is f of x minus g of x divided by 2, right? Which is the one that we were trying to find? The one across from the 60, right? So if all of this is x, and all of this takes the place of that x right there, right? So it'll be f of x minus g of x divided by 2, all of that times radical what?
3.
3. That'll be my height. Are you with me? We're trying to come up with the formula that I could use. That way I don't have to do this every single time. Once we work this out, we're going to know the formula and we're just going to memorize that formula. But this is how we're getting that formula, okay? Alright, so we said it was base times height divided by 2. So what is the base of this triangle? F of x minus g of x times the height, which was this guy over here. F of x minus g of x divided by 2 times radical 3. And then all of that divided by what? Divided by 2. That looks really ugly. Can I fix that up so that it looks a little nicer?
Yeah.
Yeah? Alright, so what do you think we're going to get there? So we got 2f of x minus g of x. We can multiply those. And that'll give us squared, right? And then we have radical 3 over 2 there, right? And then it's technically all of that divided by what? 2. So we can multiply these guys and make it what? Radical 3 over 4 times f of x minus g of x squared.
Could you pick it up a little?
Yeah.
Thanks.
And now we can use that to find the volume, right? Because that would be what we would use to find the area of each of those equilateral triangles. Okay? So the volume would be, take the constant out, and it kind of looks like the other ones that we did, right? The integral from a to b of f of x minus g of x squared. What seems to be the only thing changing on each of these formulas? The constant on the outside, right? So if we can memorize those constants and what those constants correlate to, we should be okay with the cross sections. Cool? You don't have to remember all this stuff that we did up here. You have to remember the formula. Okay, these formulas are on your little purple sheet that I gave you to review. In the very back where it says volumes by cross sections. You need to look at them, okay? Alright, and the last one is going to be this one with semicircles, okay? So, how do I find the area of a semicircle? Pi r squared divided by 2, right? Okay, so what's going to be the radius if I have a semicircle from one part of the curve to the other? Half of that top minus bottom, right?
Yes.
Okay, so radius is this divided by 2, because it's from here to here only. Yeah?
Yes.
So let's write the formula. So it's going to be pi times the radius, which is going to be f of x minus g of x divided by 2 squared, right? And then all of that divided by 2. Okay? So that technically gives us like 1/2 pi, right? If I square each one of these, it gives me f of x minus g of x squared over what? 4. And we can multiply that 4 with this 2. And that ends up giving us the constant of what in this case? Pi over 8, right? Times f of x minus g of x, what? Squared. Now that would be the area of only one semicircle. If we want all of them, we have to write an integral, right? And if I add up all of them, that's going to be equivalent to the volume. So what this one's going to be what? Pi over 8 times the integral from a to b. Oh, what do you know? F of x minus g of x, what? Cool? So what's it for a square? Square cross section. F of x minus g of x squared. What is it for equilateral triangle? Radical 3 over 4 times f of x minus g of x squared. What is it for an isosceles right triangle? Half f of x minus g of x squared. Okay? And for the semicircle? Pi over 8 f of x minus g of x squared. How about for circular cross sections? What if they were circular cross sections? That means they would have to be perpendicular to the y-axis. How do we get the area of circles, guys? Pi r squared, right? So that would be pi times f of x minus g of x
Over 2 squared.
squared, right? Over 2, y over 2.
So that's
Oh, the radius, right? So yeah, the radius would be half because the whole thing would be f of x minus g of x would be the diameter, right? So you're right. Yeah.
But that's just the radius of over 2.
So what would it end up being?
Pi over 4.
Pi over 4?
Yeah, how?
Very good. Pi over 4 times f of x minus g of x. Yeah. Okay, so the main thing that you wanna pick up from here is whenever you're trying to find the volume using cross sections, it's very simple. You're gonna set up an integral from wherever to wherever, and the formula that you're gonna use here is gonna be the area of the cross section. Okay, so all you have to do is find a formula for the area of the cross section and then integrate it from A to B. Okay, with respect to X or with respect to Y, depending on what the cross sections are perpendicular to. Okay? You understand? Alright, so there's a couple of examples there that I don't think we're gonna have time for. So we'll do those on Monday. Right? You should be able to now go back to the problems that were on the free response that we put a cross on and try them out now. Okay, pay attention to what kind of cross sections they're making, so that way you can set up your integral. Alright? Remember, if it says perpendicular to the x-axis, that's a what kind of problem? dx. So I do top minus bottom for my radius, okay? Or for whatever I'm looking for, the length or whatever. If it's perpendicular to the y, dy, right minus left. Good? Alright, we'll finish this on Monday.